All right, so for the continuation of finding annihilators, now let's look at the example f of x is 2x e to the 3x. So we'll kind of first tell you the answer first. The answer is going to be d minus 3 squared is your annihilator. And the idea is that this x in front of the e to the 3x tells you that you have a repeated root for your auxiliary equation. So therefore you know that 3 is showing up twice as a factor. So you're kind of working backwards. Again, you know that you must have a y1 of x equaling e to the 3x, and then a y2 of x must be x e to the 3x. So that only happens when you've got r1 and r2 both equal to 3, so you've got your repeat of your factor. So that's one way of looking at it. Another thing you could do is you could actually calculate d minus 3 and apply it twice to the function, and you would get 0. And it's not practical to do that, but the idea is, again, that if you were to take d minus 3 and apply this operator to 2x e to the 3x, you would get 0, because this is equivalent to a d squared minus 6 times d plus 9 times, or applied to, our 2x e to 3x. And that would give you 0. You would take the second derivative of this function and then minus 6 times the derivative of the function and then 9 times that function, and everything would cancel out to 0. Again, we won't go through that calculation here because it's very long and tedious, but the idea is you could go ahead and do it. So again, in this problem, your operator is d minus 3 squared for your annihilator. And if by chance you had a 2x squared e to the 3x, then it would be d minus 3 cubed, and so on. It's always one power higher than the exponent on the x in front of the exponential function. All right, so now let's move on to our first trig function. F of x is equal to the cosine of 4x. And again, there's multiple ways to think about it. We'll first tell you the answer. The answer is going to be d squared plus 16. That we're applying to the function cosine of 4x to get 0. And again, different ways to look at it. One is if you had an r squared plus 16 and you were to solve it, you get r is equal to plus or minus 4i, which would give you sine and cosine of 4t as your solutions, and that's what we're working from here. Or you could think of it this way. If I take the second derivative of cosine, I would have, first of all, f prime of x is equal to negative 4 sine 4x. And then the second derivative would be a negative 16 cosine 4x. So you think about it, taking the second derivative, which is negative 16 cosine 4x, and then adding it to 4 times, or 16 times, I should say, the original cosine, you'll get 0. So again, the second derivative plus 16 times the original will cancel out and give you 0. So that's how we know that d squared plus 16 is your differential operator for this cosine function. And it would be exactly the same for the sine of 4x as well. Both sine of 4x and cosine of 4x both have the same annihilator.